Alright, good afternoon everybody. This is the 9.3. So we're going to start talking about significance tests for means. So we've done significance tests for proportions and we've done significance tests for two proportions. So what we're talking about is writing our null hypothesis, our alternate hypothesis, testing it, and then looking at our p-value to figure out whether we can accept, or whether we can reject the null hypothesis or fail to reject the null hypothesis. So that's what we're looking at today. This first video is going to be the first example, and then I'm going to make a second video for the other two, depending on whether you need a little more hand-holding with those or not. Everything is relatively the same, except that we're using t-values. And so when we get to our distribution, we're going to be using the t-distribution instead of the normal distribution. So we started talking about that last time with confidence intervals. So I'll show you where all the calculator steps and all of that are. All right, so first off, problem 1. It's recommended that teenagers get 8 hours of sleep a night. Miss G believes her AP Stat students are getting less than the recommended 8 hours of sleep per night. I am shocked to think you guys are getting less than 8 hours of sleep a night. To test her belief, she took a random sample of 10 students in class and recorded the number of hours of sleep for each. Does her data provide convincing evidence that the AP Stat students get less than 8 hours of sleep per night using alpha equal to 0.05? So this is actually 10 of y'all's actual answers from the survey you did at the beginning of the year. So I did pull that one back out. All right, so first thing we need to do is calculate the mean and the standard deviation. So we got to put the data in our calculator. So we went over this last time when we were doing confidence intervals. So we need to go to our spreadsheet and we need to type in our numbers. So it doesn't matter what order you do it in, just get them all in there. There's only 10, so it shouldn't take too long. Make sure you proofread, because it's really easy to miss a decimal point or something like that, especially if you're using the online calculator. Alright, so I've typed in all 10 of my numbers. Scrolling back up right quick. Everything looks good. Okay. So now I need to get my mean and standard deviation. So I'm going to hit menu, 4, 1, 1. Alright, I need to tell it what I want it to look at. So, I forgot to name it. But it's sleep. Let me call it that. I named it earlier. Alright, and so over here, there we go. So we have our X bar, which is our mean for the sample, is 6.75. And then our standard deviation for the sample, which is S sub X, is 0.890 if we round that off. Alright, so if they don't give you that in the problem, do that part first. It'll just make your life easier down the road when you actually jump into the test. Okay, so now we got to talk about the parameter, our statistic, and our significance level. Alright, so our parameter is mu. And in this case, mu is the true mean. That is not how you spell that word. The true mean of how many hours of sleep y'all get a night. Alright, so our statistic, we've just found it. That's our X bar. So that's why we do that work first. It makes our life a little easier. Alright, so X bar equals 6.75. And then our significance level, we're at alpha equals 0.05. Generally, that's what we're going to use. They usually tell you that in the problem. If they don't, you can assume it. Every once in a blue moon, you might get one that has a lower significance level or a higher significance level. So if they tell you something different, use that. But if not, just go with 0.05. Alright, cool. So we named those pieces. So now we need to do our hypotheses. Alright, so for the null hypothesis, if in a perfect world, all of you would be getting 8 hours of sleep. So mu equals 8. That's my null hypothesis. My alternate hypothesis is I think that's BS and you guys are all getting a lot less than that. So mu is less than 8. That's my alternate hypothesis. All right, so now we got to go through and see if we have enough information to reject the null or if we have to fail to reject. All right, so the procedure we're doing is a one sample t-test for means. All right, same naming convention we've been using this whole inference units. All right, so what conditions must be met? Same deal as what we did for a confidence interval. So first it's got to be random, just like it's been for all of these. And up there I took a random sample, which it was. It was the every other one of you that filled out the survey. Then 10%. This one is not met. All right, 10 of you are not greater than 10% of my AP, or less than 10% of my AP Stat students. So that one's a yes, that one's a no. And put a pin in that for a second, we'll come back to it. And then last thing we got to look at is it normal or not? So first off, I didn't say that it was normal in the problem, so we can't go that route. Second, we would check for a central limit theorem, meaning our sample has to be 30 or larger. It's not. It's 10, so that's not enough. So our third option is to go look at the graph. So we're going to go back, we're going to hit the on button, and we're going to hit our bar graph. Then I'm going to click on the x-axis, and I'm going to click on sleep, and we're going to get our picture. All right, so looking at that, we don't have any obvious outliers, and there's not any obvious skew, so we can go ahead and assume that it's normal. Okay, so remember I said put a pin in that for a second. So what we can say, and you can say this here, you could also say this at the end in your conclusion, but if you have something like this and you want to keep going with your test even though it doesn't meet one of the conditions, you can just say, so here we're going to say we will proceed, but should treat our answer with our results with caution due to not meeting the 10% condition. All right, so we've done basically the state and the plan. Now we get to actually jump into doing the calculations. So we're using the same test statistic formula that we've been using. Before we do that, though, we do need to establish our mean and the standard deviation of the sampling distribution. So for means, they're the same. So the mean of our sampling distribution is going to be what we thought our null hypothesis was, which is 8. All right, this standard deviation formula, same as what we were using last time for confidence intervals. So it's the standard deviation over the square root of n. So standard deviation was 890, sorry, over the square root of 10. Mash your buttons. Oops. So we got to go back to the calculator. All right, so we have 0.890 divided by the square root of 10. And that's going to give us 0.281. Okay, so if we have those, now we can kind of jump in and do the rest of them. All right, so our general formula is test statistic equals our statistic minus the null over our standard error. So our test statistic is t, our stat is x bar, our null is mu, over our standard error, which is that formula we just calculated, Sx over the square root of 10. So when we plug in our numbers, we've got 6.75 for our x bar, our mu is 8, over 0.281 that we just found. Then we can jump over to our calculator and do that part. And we end up with, for our t, negative 0.448. So that's our t value. Now for our picture. Since this is a t, what we want to use for this is we do want to use our unstandardized graph. All right, it's a little easier to draw. So first off, it's just t and then your degrees of freedom. So our degrees of freedom, there were 10 in our sample, so 10 minus 1 would be 9. So that's all I would have to do to label that. My mean is 8. We had 6.75. And if you go back and look at the alternate hypothesis, it was less than. So I'm going to shade below. All right, so that's what our picture should look like. All right, last thing to do now is to go through and actually find our p-value. And you can do that using the table. It is much easier to just go ahead and use the calculator. But since we're not using a normal distribution, we're using a t-distribution, which is a kind of normal distribution, but it's not the norm CDF. It's actually t-CDF. So our p-value equals t-CDF. And that's lower, upper, and then our degrees of freedom. So our lower would be negative 9999. Our upper is our t-value in this case, our test statistic. So negative 4.448. And then our degrees of freedom we said was 9. All right, so in the calculator to find that, you want to hit Menu, 6, and then Distributions, which is 5. And then we're doing t-CDF. So you can leave the negative infinity in there. You can type it negative 999. It's fine either way. Then we're going to have our t-value, which is negative 4.448. And then our degrees of freedom, which was 9. And there we go. So we get a p-value of 0.000802. That is definitely less than 0.05, so we can reject our null hypothesis. All right, and that means we have convincing evidence that y'all aren't getting enough sleep. Or at least y'all in August were not getting enough sleep. All right, So that's the example of working all the way through one of these. We're going to do 2 more in the next video, and I'll see you then.